All right, everyone, welcome. I'm Dr. Saurang Suresh, and today we're going to tackle one of the trickiest parts of aesthetic dentistry, color. My goal here is simple, to give you a solid framework that not only helps you ace your exams, but more importantly, makes you feel way more confident when you're chairside.
So here's our game plan for today. We're going to start with why this is so tough in the first place, then we'll get into the science of how we even see color, and finally, we'll tie it all together with a practical system you can use with your very next patient.
Yeah, we've all been there, right? You're holding that shade guide up, squinting under the operatory light, just feeling uncertain. So let's break down exactly why that is, and we'll turn that uncertainty into a real sense of control. This is the question. It can keep you up at night. But here's the secret, okay? The answer isn't about buying a fancier composite kit or some new high-tech gadget. Nope. The real solution is in understanding the fundamental science of what color actually is.
Okay, if you remember one thing today, let it be this. Color is not in the tooth. It's not a static property of an object. Color is a perception. It's an event that happens when three things come together: a light source, an object, and you, the observer. You change any one of those three, and the color you see completely changes.
Okay, so let's dig into those three factors. I want you to really picture this as a triangle, because if you take away any one of the sides, the whole experience of color just collapses. It doesn't happen.
And these are our three pillars. You've got the light source you're using, the object you're looking at, in our case the tooth, and the observer, which is you. So our whole goal from here on out is to figure out how we can understand and control each of these three variables.
The light source is, well, it's everything. Think about it. That shade you picked under your super bright kind of bluish operatory light, why does it suddenly look totally different when your patient smiles in the waiting room or steps outside? It's because the light source itself, the very energy hitting that tooth, has changed.
Now, for the object itself, the tooth. A tooth appears the way it does because of how its unique structure of enamel and dentin plays with light. It reflects some wavelengths, it absorbs others, and it even lets some pass right through. It's a really dynamic interaction. And this is where all that physics stuff becomes super practical. Just look at this chart. When a tooth absorbs more light, it just looks darker. Simple. When it transmits more light, we get that beautiful natural translucency at the incisal edge. It's not magic, you know. It's just physics happening right in front of us.
All right. Let's move on to that final corner of our triangle, the observer. Let's see how our own biology builds this perception, because what's happening inside your eye and your brain is just as important as the light or the tooth.
You see, your eye is not just a passive little camera capturing a picture of the world. No way. It's an active processor. The entire experience of color is constructed by these amazing, specialized cells in your retina. Now get this, it's pretty wild. Our eyes don't actually see every individual color. They have these specialized receptors, the cone cells, that are specifically tuned to red, green, and blue light. That's it. Every single other color we perceive is just our brain mixing and interpreting the signals from those three channels. This one biological fact is the foundation for everything from your TV screen to how we see teeth.
So, that brings up a huge problem, right? If color is this personal, subjective experience, how in the world do we communicate it accurately to someone else, like a lab technician? We need a standardized system, a common language to describe it objectively. And this is our Rosetta Stone for color, the Munsell color system. Albert Munsell gave us this brilliant model that breaks color down into three simple, manageable dimensions. And let me tell you, it's the foundation for pretty much every dental shade guide you'll ever pick up, so understanding it is absolutely non-negotiable. Okay, so let's learn the vocabulary. Mastering these three terms, hue, value, and chroma, I'm telling you, this is essential stuff, both for your exams and, way more importantly, for your actual clinical work.
First up, hue. This is the easy one. Think of hue as just the basic color family. You know the letters on the Vita shade guide? A, B, C, and D? That's primarily differentiating by hue. Are we in the reddish-brown family? That's A. The reddish-yellow family? That's B.
So as you can see, hue just answers the first basic question. What color is it? Is it reddish, yellowish, grayish? It's our first level of classification.
Okay, now I need everyone to really lean in for this one. I'm serious. Value. This is, without a doubt, the single most critical dimension in restorative dentistry.
Why? Because our eyes are way more sensitive to changes in lightness and darkness than they are to little shifts in color. If you get the value wrong, the restoration will stick out like a sore thumb and nothing else will matter.
Nailing the value is what makes a restoration truly disappear. And hey, here's a clinical tip you can use tomorrow. When you're comparing the shade tab to the tooth, just squint your eyes. Go on, try it. It blurs out the color, the hue and chroma, and it forces your eye to focus only on the lightness or darkness. You're isolating the value. It's an old-school trick that works like a charm.
And last but not least, we have Chroma. Think of Chroma like the volume knob for the color. Once you've picked the hue, the color family, Chroma tells you how intense that color is. Is it a weak, pale yellow, or is it a strong, super saturated yellow? And this is exactly what the numbers on your shade guide are telling you. Think about the A shades, A1, A2, A3. They all have the same hue, right? They're all in that A family. The number, 1, 2, 3, is just telling you the chroma is increasing. You're turning up the intensity of that reddish-brown color. Okay, so we've got the theory down. We understand the triangle of perception. We can speak the language of hue, value, and chroma. So what's the most important part? How do we put all this together into a system that actually works in the clinic? This is your clinical workflow. But wait, look very closely at the order here. It's different from how we learned the terms. We learned hue, then value, then chroma. But we select value first, always. Remember what I said? It's the most important thing. You have to match the lightness first. Once you've locked that in, then you dial in the color intensity, the chroma. And only at the very end do you confirm the underlying color family, the hue. Following this order will absolutely revolutionize your results, I promise.
So I'll leave you with this question to think about. The next time a patient sits in your chair for that really tough single anterior restoration, how are you going to do it differently? Will you think about the light source? Are you going to squint your eyes to nail down the value first? Because applying these principles isn't just about passing a test. It's the first real step on the path to clinical mastery.